Have you ever looked up at the night sky and wondered what else is zipping around besides stars and planets? There is a lot more up there than you might think, including a growing problem for space travel and exploration. Orbital debris, often called space junk, is essentially any human-made object orbiting Earth that no longer serves a useful function. This can include an astonishing variety of items, ranging from tiny paint flecks to entire defunct satellites. The main kinds of objects that become orbital debris originate from several distinct sources. One significant category includes spent rocket stages, which are the large sections of launch vehicles that detach after they have propelled a spacecraft into orbit. Another major contributor is defunct spacecraft themselves, meaning satellites and probes that have either reached the end of their operational lives or experienced critical failures. Collisions between objects in space are also a primary factor, as these high-speed impacts can shatter larger pieces into thousands of smaller, fast-moving fragments. Additionally, smaller items such as tools or equipment accidentally dropped by astronauts during spacewalks can also become persistent pieces of debris. The space environment also contains countless minute particles like pieces of insulation, tiny metal shards, and even solidified drops of coolant, all hurtling through orbit. Understanding these types of debris is critical because each piece, no matter its size, poses a risk to active satellites and future space missions. Tracking and mitigating this debris involves international cooperation and technological innovation. Knowing the origins helps engineers design satellites and rockets that minimize fragmentation and allow for deorbiting at the end of their mission. This proactive approach helps to keep crucial orbital paths clear for essential services like weather forecasting, global positioning systems, and communication networks. It is worth noting an important concept called the Kessler syndrome, named after scientist Donald Kessler. This describes a scenario where the density of objects in low Earth orbit becomes so high that collisions between them generate more debris, which then increases the likelihood of further collisions. This creates a cascade effect, potentially making certain orbital regions unusable for generations. While this is a worst-case scenario, understanding the types of debris and their origins is our first step toward prevention. Ultimately, recognizing the diverse array of objects that contribute to orbital debris allows us to appreciate the complex challenges of operating in space. It underscores the importance of responsible space practices and innovative solutions to preserve this vital frontier for future scientific discovery and technological advancement, ensuring that our access to space remains safe and sustainable.